Yeah.
Hello.
Hi, how are you?
Good. How are you?
Good. How'd you do this week?
Um, it wasn't bad. The homework for today, it wasn't bad. It made sense. A lot more sense, I think, than the previous homework stuff. Yeah. How'd you do?
I liked it. It was good.
Yeah.
I actually went back and looked at some of the other classmates' videos to see if I could understand the type 1 and type 2.
Oh, yeah, yeah.
And tried to figure out why we got our things wrong, our answers. So hopefully I'll have that. I think I have that figured out.
Yeah.
So have you heard from David or anybody?
I haven't heard from anybody. Nope. Yeah. I don't know. Yeah.
I guess if they were going to be on, they would be on.
Yeah, because I don't know if maybe some of them dropped a class or I don't know. But
Yeah, maybe the 2 girls.
yeah, but like you said, if they wanted to be doing it, they would be. But
Yeah.
yeah.
Okay. So have you done? Should we get started?
Yeah. I think that'd be good.
All right. I kind of feel bad for David. I feel like I should call him. I know he was struggling in the beginning.
Yeah. Yeah, you invited him though, so on the
Yeah.
right? Yeah.
Yeah. Maybe I'll call him after this and say, hey, are you still going to do this? Need help catching up or whatever.
Yeah.
Okay. So do you want to just go through the whole thing or part 2 or what do you want to do?
You pretty much get all just like the part 1, don't you? Pretty much.
Yeah.
Yeah, we could probably just start on part 2
Okay.
and then because it wasn't too bad. I mean, when it has formulas and stuff, it's pretty straightforward.
Yeah. I actually kind of did that stuff because I wanted to make sure I got it.
Yeah.
Okay.
Okay.
I'll do number. Oh, David, you're here.
Yeah, hey.
Hey, what's up, man?
Not much. How you guys doing?
Pretty good. How you doing?
Good. I'm just watching my niece, so I'm trying to.
I like your mouse, in fact. Your Minnie Mouse.
Yeah, it's cool stuff. Playing Mr. Mom for the next week.
Cool.
You guys already do everything?
No, we just are starting.
Oh, okay.
So do we need to go through part 1? Do you know the?
Oh yeah, I did that last night. I did part 1 last night. Number 4 is the only one I didn't really understand. Because it's like right in the equation. And the equation I wrote down was it was just standard deviation over square root of n. And when I looked on the key, oh no. Number 2. Number 2 is the only one I don't understand.
Right, the formula. So the margin of error is
plus or minus 3.
Huh?
It's plus or minus 3, right?
Well, no, the equation you use for that Or is it asking, oh yeah, it wants to know the formula for it.
Mm-hmm.
And so the formula was just the z-score times, what was it?
The standard deviation divided by the square root of the sample size. Yeah.
The square root of n?
Yeah.
Mm-hmm.
Okay, I got that right then. Because like on the key, it just gave you like, it was just like a paragraph on something.
Oh, yeah.
Cool.
Okay. All right.
So, do you guys just want to start on part 2 then?
Yeah.
All right. So, 6 is what are the 3 assumptions that needs to be checked before you compute a confidence interval for a mean? So, isn't it like the 3 rules kind of? So like the sample, a simple random sample is taken from a population. The distribution of a sample mean is normally distributed, and sigma is assumed to be known.
Yeah, that's what I have.
Yeah.
That's what I.
All right.
Okay, I'll go. Says the graduate management admission test, GMAT, is used as an admission criterion in many Masters of Business Administration programs. The BYUI professor would like to estimate the population mean from a simple random sample of 50 people's scores. The sample mean for these 50 students is 541. Assuming
Are you guys doing the quiz already? Are you guys doing the quiz already?
No, part 2.
Part 2. Okay.
Just reading that little paragraph.
Right.
The sample mean for these 50 students is 541. Assuming the population standard deviation is 32, answer the following questions. So they want to know, what is the point estimate for the population mean? And
Is it just 541?
Yeah. Because it's the point on the point estimate is the point on the line where you guess the mean is. Because like they say, you'll never really know what the true mean is, because we'll never know the true population.
Yeah.
So for this particular answer, it's 541.
All right.
Number 8.
Yeah, number 8.
Yeah.
Okay, so create a 95% confidence interval for the population mean. Show all your work below. Is that the one where we do the sample mean minus 2 times standard deviation over square root of n, and then you find the 2?
Yeah, but it's more specific. Because you go on the applet.
Oh, okay.
And find the z-score of 95, which is 1.96.
Oh, yeah.
So you'd plug in 541 minus 1.96 and times it by the standard deviation, which is 32, divided by the sample mean, which is 50.
Get a pen real quick.
Okay. When I was first doing these, I would do both the problems all out, but all you really have to do is that first half of the equation, and then you either add, what do they call it, the the margin of error. You just add the sample mean or subtract that margin of error to the sample mean instead of doing the whole thing again.
So then, like say you did a subtraction one first and you got 532.13, you would do what instead of doing the whole equation?
So your whole equation looks like this. It's 541 minus 1.96 times 30. So you see on both those equations it's the same. So
Yeah.
once you figure out the standard deviation divided by the sample mean and you times it by that 1.96, that number was 8.86994, a big long one. So you do 541 minus that number, and then you go 541 plus that number, and that will give you your two answers.
Oh, okay.
You know, instead of...
Yeah.
Because you're basically just doing the same thing again.
Yeah. Okay. All right. So did you guys get 532.13 and 549.87?
Yes, I did.
Yeah, I don't have a calculator. I'm just winging it. Sorry, guys.
That's okay. But you know how to get it?
Yeah, I got the equation. Thanks.
Okay. All right.
All right. So yeah, 9. Say that the sample size changes to 100. Now compute a 95% confidence interval with the same point estimate. Same thing.
Same thing, but you just put 100 down there. And sometimes instead of writing that out, I just know that the square root of 100 is 10. Just do 32 divided by 10.
Alright, so just 534.73 and 547.27.
Yeah, that's what I got. David, I got your message. Did you ever find that channel?
Yeah.
Okay.
Yeah, I did.
It was really long.
Yeah, you guys were on it for like 2 hours.
I know. We couldn't figure out the stupid type 1, type 2.
Yeah, it was difficult. So at number 9, it's not telling me what the sample size changed to.
It's the same.
Oh, it's the same answer?
Yeah, it's just going off that all the information, using the same standard deviation. The only thing that changed was the sample size.
What did it change to?
100, because in the number 8 it was 50.
Oh. Huh. Okay.
You see it?
On my on On part 2 that I have downloaded here, it just says, on number 9, it says, say that the sample size changes to, and I have a blank, and then it says, now compute a 95% confidence interval with the same point estimate.
So it doesn't tell you the 100?
No.
Huh. That's convenient.
Is it my turn, or are you reading, Sadie?
Go ahead, David.
Okay, how does the margin of error for the 95% confidence interval of the same size 50 compared to the margin of error of 100?
So when I was looking at this, you know the answer, David?
No. Go for it.
When I was looking at this, I was comparing those interval numbers.
Mm-hmm.
Because with the 90, or with the sample size of 100, these intervals were higher than the other one. But then I was looking, that's not what you compare. You compare that big, long, the margin of error number.
Yeah.
And so it's smaller. It's smaller. The bigger the sample size, the smaller the margin of error is.
Yeah.
Okay. Create a 90% confidence interval for the original 50 students. So the same thing as before, we're just changing the 1.96 to 1.645.
Oh, thanks. All right, so just 533.56 and 548.44.
Yeah.
Okay.
That's what I got.
All right.
Did you guys just unhighlight the sides and just highlight the middle?
For to get the 95 and the 90 percentile?
Yeah.
Yeah, just do the middle.
Okay. It's 1.65.
Yeah, for the 90.
Okay.
0.645.
And in the reading somewhere it said, I couldn't find it, I was trying to go back and find it, but they say usually use 90, 95, and 99, and they had all those Z-scores.
Oh, yeah. They just usually those three.
Yeah.
So I need to write them down, but I couldn't find them. Okay.
All right, so 12. How does the margin of error for the 95% confidence interval that you computed in question A compare to the margin of error for the 90% confidence interval that you computed in question 11?
Question 8 compared to 11.
So it gets smaller. Wait.
Like as the interval gets smaller, the margin gets smaller?
Yeah, would it
Yeah.
be like number 5 yesterday in part 1 where it says like as the margin of error goes down, the z-score goes down, or as the margin of error goes up, the z-score goes up?
Yeah.
Mm.
Is that what it is?
Well, yeah. Your z-score goes up, then yeah, the margin will go up. Is that what the T says?
It says the margin of error gets smaller as the level of confidence grows smaller.
Oh,
Yeah, that's what I meant. I'm just kidding.
the margin of error gets smaller as the level of confidence grows smaller. But, let's see. Okay, right.
Yeah.
So the level of confidence is like your z-score.
Mm-hmm.
So if your z-score is smaller, your margin of error
Error is smaller. Yeah. Yeah.
Hey, I'll go. The BYU, I don't know if it's my turn, but I'll read. The BYUI professor would like to repeat the experiment, but he wants to make sure he has enough students in his sample to ensure that the margin of error is 5. How many students will need to be in his sample to ensure that his level of accuracy for a 95% confidence level? So the equation for that it's called the sample size formula. So you're solving for the sample size, which is n. So it's going to be your z-score times sigma, or your standard deviation, divided by the
Margin of error.
and then you square that whole thing after you square it. So for the 95, it would be 1.96. And the standard deviation was 32. You divide that by 5. Can I put you down?
So, I got 157.352.
That's what I got. But then, did you get that, David? Or are you not computing it?
I'm doing it on paper.
Oh, awesome.
Yeah, you guys can keep on keeping on. I'll figure it out.
Well, you just have to remember whatever answer you get, if there's a decimal at the end, if it's not a whole number, you always round up to the next whole number.
Okay.
So it was 157.352, so you'd round it up to 158.
Okay.
Because you can't sample part of a person. Part of something.
Alright.
Okay. So I'm going to open up the quiz.
Yeah.
So, does everybody have it open yet?
Yeah, I have mine open.
Yes.
Okay. The first two are true. Okay, number 3. Find the margin of error for a 90% confidence level interval. Sorry, I can't read. When the standard deviation is 50 and the sample size is 25. So the equation you use is hang on, I gotta move this kid, he's loud.
Did you guys get 157.4 on that last one?
No, let me see. Yeah, so you would just round it to 158.
158. Okay,
Yeah.
cool. Cool.
Job with your skills there,
I still got it.
without the calculator. Okay. So, okay, the z-score for 90% is
1.645.
1.645.
So that would be 1.645 times 50 divided by the square root of 25.
Yeah. Did you guys get it?
Yeah.
I think so. I think I got 16.45.
Yeah,
That's
that's
what
what I got.
But it says rounds in the 3 decimal places. Would it do that?
Yeah, because there's only 2, I guess. So, next question.
Which of the following statements is true? The mean is a point estimator for the sample mean, or standard deviation is an interval estimator for standard deviation squared. Sample mean is a point estimator for the mean, or yeah, I don't know this one.
I'm thinking that the sample mean is a point estimator of the mean. That's the population mean. Isn't that what U is the population mean?
Yeah.
Yes.
Yeah, I was either between that one or the mean is a point estimator of the sample mean.
Because, yeah, a point estimator is just a point on the line that you guess where the mean is going to be. So if
Okay.
if U is the mean of the whole population,
Oh, so then it's
sample mean is just
the
kind of a
specific.
guesstimate of it.
Okay.
Is
All right.
that right?
That makes sense to me.
So it's X, the line over it, is a point estimator for the U?
Yeah.
No. Oh, yeah. Okay.
All right. So 5, Gina wants to construct a 95% confidence interval for GMAT scores. She knows the standard deviation equals 113. She collects a simple random sample of 64 and computes a sample mean of 526. Use this information for questions 5 through 8. What is the lower limit of this confidence interval?
So to do that, you do the x minus all the rest of the equation. So it'd be 526 minus something. Let's see. 526 minus
1.96.
what was the z-score of that? 95?
1.96.
1.46?
96.
1.960.
96 times 133.
113.
113
Oh, good job. 113
divided
by
by
the deviation of 64.
4.
So 113 divided by 8. Times so the margin of error I got was 27.685.
Whoa. How'd you do it again? 526 minus 1.96 times 113 divided by 8.
Yeah, so your first step is going to take the square root of 64, which would be 8.
Uh-huh.
And then you go 113 divided by 8.
Which is 14.125.
Uh-huh. And then times that by 1.96.
Oh,
And that gives your margin of error.
okay.
So with that number, you can subtract that from the sample mean, and you can add it to the sample mean. And to get the lower end, we're going to subtract it from the sample mean.
Okay. What'd you get?
I got 498.315.
That's
That's
like
what I got.
Okay. So 498. So then for the upper one, you have to add. I haven't done that one yet. 526 plus your margin of error. 6. I got 553. 0.685.
Yeah.
Sweet. Yep.
Okay.
What would happen to the width of the confidence interval if Gina increased the sample size?
It would decrease.
Oh yeah, it would decrease, huh?
Yeah. Are we all good there?
I'm gonna believe you. I was just looking at my notes, just seeing what it said.
Okay. Yeah, because if you have a increased sample size, your what is it? Margin of error decreases. So
Yeah, that's what it says here. The sample size increase, the width of confidence interval will decrease. Because the sample size, let's see, because the sample size you're dividing it by that. So if you divide it by a bigger number, it's obviously going to be smaller. Okay.
yeah.
Okay. What would happen to the width of the confidence interval if Gina changed it to a 99% confidence interval? What would happen?
Let's see.
In the notes it says increasing the confidence level will lead to larger values of the z-score. If the z-score is increased, then the margin of error would increase. This would lead to a wider confidence interval. So it's asking what happened to the width.
It would increase.
So it would increase.
No. I'm just gonna.
Okay. So that would make sense because the confidence interval is the z-score. So if you're multiplying something by a bigger number, it's going to get bigger.
Yeah.
Yeah.
Okay.
Okay, so 9 Bright Bulb Light Bulb Company is planning a study to assess the average life expectancy of their light bulbs. They know the standard deviation is 400 hours. They want a 95% confidence interval with a margin of error of 50 hours. What sample size do they need? Round to the nearest whole number. So
N equals z times the standard deviation divided by m. So
yeah.
So the 95th percentile is, I need to write this down. Is it 1.645?
1.96.
Oh,
It was close.
1.96 times, what's the standard deviation? Oh, 400.
400.
Divided by 50. Hang on, buddy. So I got 15.68, and then you have to square that.
$15.68.
Yeah, then you have to square it.
Yeah. So
I keep wanting to do that.
246.
Oh yeah, you round to the nearest whole number. Yep.
Okay.
Is there a square button in like calculators? Right now?
On my phone, it's an X with a 2 with a square at the top of it.
Nah. Got it.
Okay. You ready for the next one?
Yeah.
Okay. So number 10, okay, the mean salary of actuaries, what is actuaries, is 100, hang on, my screen keeps going away. Okay, is $100,000 and the standard deviation is $36,730. You're interested in to know the mean salary for women actuaries is different from the population mean, but are not sure if it is higher or lower. You set up a hypothesis test with level of significance 0.05, and the null hypothesis is equal to 100,000, and the alternate hypothesis is equal to 100,000. You collect a simple random of 36 women's salaries to find that the what is that? Sample mean is $111,000. Use this information to answer. Okay. So what is the lower limit of this 95 confidence interval? Okay.
So, limit to 111,000.
How do you... Okay, so yeah. So 111,000 minus
1.96. 36,730 divided by the square root of 36.
I got mine.
I got mine.
I got mine too.
Okay, I got 99,001.53.
Yeah. That's what I got.
Wait a minute. I didn't get that.
I got that as well.
Okay, so you went 36,730 divided by 6.
Yeah.
And I got 612166 7, and times that by 1.96, and I got 11.998466666 whatever 7.
Yeah.
And so then
Correct that.
I see what I did. Wait a minute. Yeah, I subtracted the wrong deal. Okay, so I'm gonna do that again. So it's gonna be you guys are right. 11 minus 11.9. So what am I subtracting from the 111,000?
11,998.467.
I'm going 111,000
Minus.
minus 11.9984667.
No, 11,998.467.
Okay, I've got a decimal wrong here. What's going on? Okay, I know what I did. Instead of 36,000, I went 36.730 instead of a comma. Okay. So tell me what your answer was.
99,001.
So 99001.
Yeah. So to the nearest whole number, would it just be 2 at the end?
Would we add that same number to 111,000?
Mm-hmm.
If we're adding the 11,998, I get 122,998.
So what'd you get?
122,998.
Okay, that's what I got too.
That's what I got.
Except on that other, did you get that, BG?
No. I got 111,011.998.
Oh, well, yeah, that's for the. That's the the margin of error is 11,998. You're adding that. You need to add that to the 111,000
Oh, okay.
for number 11.
Yeah.
And yeah, you're right. On number 10, it is 99,002. because you round it up.
Yeah.
Okay. So I got the same as you, David.
So we're gonna stick with 122,998.
Yeah, we'll have to see if BG gets it too.
Yeah.
Okay.
All right.
So the next one wants to know what the 3 requirements are, and I think it's all of them.
Yeah, it's all of them.
Okay, let's check our numbers.
All right.
So 3 was 16.45, 4 was X is a point estimate review, 5 was 498.315, 6 was 553.685, 7 was decrease, 8 was increase. Okay, 9 was 246.
Mm-hmm.
10 was 99002. 11 was 122,998.
What was 11?
122,998.
Okay.
Is that right?
Yeah.
Alright. You submitting them?
Yep.
Yep. See, David, we missed you last time. We missed a few.
Oh, for real?
Yeah.
Because you guys need that third sign of assurance, right?
Yes, we need that third witness.
There it is. Yeah, yeah, that third witness. Cool, 100%.
Okay. Well, yeah. The type 1 and type 2 threw me off. I think I got it now. Type 1 is when you reject the null when it's really
True.
true. Type 2 is when you fail to reject the null when it's really false.
Yeah.
Okay. I don't know why it was so hard to wrap my head around, but it was.
Yeah. All right.
Okay. Well, we'll see you guys Thursday.
All righty.
Okay.
Later.
All right. Later.
Bye.